Hello everyone. Let us start with next numerical, which is on normalized frequency of optical fiber. There is one equation for normalized frequency. Normalized frequency is given by V, and the formula for normalized frequency is V equals to pi d upon lambda into numerical aperture. Now let us read the given problem. A step index fiber has a core diameter of 29.29 into 10 to the power minus 6 meter. The refractive indices of core and cladding are 1.52 and 1.5189 respectively. If the light of wavelength 1.3 micrometer is transmitted through the fiber, determine normalized frequency of the fiber. Here core diameter is given, refractive index of core is given, that is N1, refractive index of cladding is given, that is N2, and wavelength, that is lambda, is also given. Let us write the given data. Diameter is given 29 into 10 to the power minus 6 meter. N1 is 1.52, N2 is 1.5189, and lambda is 1.3 micrometer. And the formula for normalized frequency is V is equals to pi d upon lambda into numerical aperture. As we know that numerical aperture is given by under root of n1 square minus n2 square. So the formula becomes pi d upon lambda into under root of n1 square minus n2 square. Now we know d, we know the value of lambda, we also know n1 and n2, and unknown is v. From this we can find out v. Let us substitute the values, given values. Pi into d is 29 into 10 to the power minus 6 upon lambda. Lambda is 1.3 micrometer, 1.3 into 10 to the power minus 6 into n1 under root of n1 square minus n2 square, 1.52 square minus 1.5189 square. And the value of normalized frequency we got is 4.0519. Here we can also find out number of modes which are transmitting through the optical fiber. Number of modes is given by V square upon 2. V is 4.0519 upon 2. It is equals to 8.20, that is nearly equals to 8. So here normalized frequency is asked and it is 4.0519. Such type of numericals are asked for 6 marks. Let us solve the next numerical. Calculate the number of modes of a step index optical fiber of diameter 40 micrometer if its core and cladding refractive indices are 1.50 and 1.46 respectively. Wavelength of the light is 1.5 micrometer. Now here it is as similar as your previous numerical. Here we have to find out the number of modes, that is n. For finding out n, we should know the value of v, that is normalized frequency. Given data is diameter is given, core refractive index is given, cladding refractive index is given, and lambda is given. So here we are writing given data. D is equals to 40 into 10 to the power minus 6, n1 is 1.50, n2 is 1.46, and lambda is 1.5 into 10 to the power minus 6, and here we have to find out n, number of modes. But for finding out number of modes we should know v. V is equals to pi d upon lambda into na. So na is under root of n1 square minus n2 square. So substitute the values here. Here we have substituted all the given data. D is 40 into 10 to the power minus 6. Lambda is 1.5 into 10 to the power minus 6. N1 is 1.50. N2 is 1.46. From this, here we have calculated normalized frequency V is equals to 28.82, and number of modes here we have we can find out from the formula n is equals to V square upon 2, as V is 28.82 whole square upon 2. So n is 415.29 and nearly it is 415. Number of modes are 415. This numerical we will solve in next lecture.